Day one at a new job. It hands you a laptop and you log in with your company credentials, just once. Then you open Slack already logged in, Jira already logged in, GitHub, Salesforce, the internal wiki, the expense tool, all of them just work. You never typed another password. You didn't create accounts on any of those. You didn't set passwords for them. You logged in once and everything opened. That's single sign-on, and the protocol quietly powering it across most enterprises is SAML. This is part 2 of our Auth Fundamentals series. Quick recap from part 1. OAuth 2 lets an app access your resources without your password using scoped tokens. OIDC adds an identity layer on top, an ID token that says who you are. Both are web-first, JSON-based, and built for the modern internet. SAML solves the same core problem, prove who you are across systems, but it was designed back in 2002 for a very different world. That context is the key to why SAML looks the way it does. Let's be precise. Single sign-on is a pattern, not a protocol. The goal is simple: authenticate once, access many systems. Without SSO, every app keeps its own user database. A password in Slack, a separate one in Jira, another in Salesforce. Each app checks you independently. With SSO, there's one central identity provider, the IdP. Every app trusts it. When you open an app, it asks the IdP, "Can you vouch for this user?" The IdP authenticates you, and the app lets you in without ever seeing your password. Those apps are called service providers. This gives enterprises 3 big wins. Security, one place to enforce MFA and revoke access. Auditing, one place to log who accessed what. And experience, one password to remember. So what is SAML? It stands for Security Assertion Markup Language. Version 2 landed in 2005, and it's still the dominant enterprise SSO standard today. The key word is assertion. The identity provider doesn't hand you a token, it hands you an assertion. An assertion is a signed XML document that says, in effect, "I, Google Workspace, confirm this user just authenticated and may access Slack." It's cryptographically signed. Slack verifies the signature came from the IdP and trusts it without ever calling the IdP during the transaction. XML-based, verbose, and built for corporate networks, not the open consumer web. Let's walk the flow. There are 2 variants, SP-initiated and IdP-initiated. We'll take the common one, SP-initiated. Step 1, you try to open Slack. You're not logged in and Slack sees you're from company.com. Step 2, Slack builds a SAML authentication request, encodes it, and redirects your browser to your company's IdP. Step 3, your browser lands on the IdP's login page. If you already signed in earlier today, it skips straight ahead. That's the sign-on once part. If not, you enter your company credentials here. Step 4, the IdP builds the SAML assertion, that signed XML document vouching for you, signed with its private key. Step 5, the IdP returns an auto-submitting form that posts the assertion back to Slack's ACS URL, its assertion consumer service. Step 6, Slack decodes it, verifies the signature with the IdP's public certificate, checks the timestamps and the audience, and creates your session. You're in. Here's the critical part. The assertion is signed end-to-end. Even though it travels through your browser, it can't be forged or tampered with. That would break the signature. This probably feels a lot like OIDC from part 1, and it should. They solve the same problem. Here's how they differ. SAML from 2002, XML-based, verbose and weak on mobile. OIDC from 2014, JSON and JWTs, compact and great on mobile. So why do enterprises still run SAML? Inertia. Salesforce, Workday, ServiceNow, SAP all built SAML support before OIDC existed. If your SSO works, it doesn't touch it. SAML also has battle-tested attribute mapping for rich user metadata. Building something new, a SaaS product, a mobile app, an API-first service. Choose OIDC integrating with enterprise IDPs like Okta or Microsoft Entra ID. You'll need SAML. And modern IDPs, Okta, Auth 0, Entra ID speak both, bridging legacy SAML apps and modern OIDC apps on top of one user directory. One more flow worth knowing. IdP-initiated SSO in the flow we just walked. You start at Slack, and it bounces you to the IDP. Here you start at the IDP. Think of a company portal with tiles for all your apps. You click the Slack tile, and the IDP posts an assertion straight to Slack. No request from Slack first. Convenient, but there's a catch. With no initial request, there's no state value to check, which leaves these flows more exposed to certain attacks. Careful implementations add extra replay prevention checks. So to recap, SSO is the pattern authenticate once, access many. The identity provider authenticates, the service providers trust it. SAML is the dominant enterprise protocol for SSO. The SP sends an authentication request, the IDP returns a signed assertion, and the SP validates it and starts your session. SAML owns the enterprise. OIDC owns modern SaaS and mobile, and modern IDPs speak both. In Part 3, the finale, we tackle LDAP, not a web SSO protocol at all, but the directory, the phone book every system we've covered reads from behind the scenes. If this helped, subscribe. See you in Part 3.